Section 13.3 Extracting Metals. In this section, you will learn about the methods to obtain metal from its compound, from its ore, and basically due to its position in the relativity series, and also describe and explain the reactions, the 5 reactions that is involved in the extraction of ions in the blast furnace. Now, metals can exist in uncombined states or combined state. In uncombined states, they are basically the unreactive metals like gold and platinum. Because they are unreactive, so they don't react to form compound easily, and hence they can be obtained from the ground in uncombined state. And basically, to get from uncombined state, you probably just need to dissolve away the sand and melt down the gold in order to get the gold itself. There's no need for any chemical reactions. In the combined states, the mineral ores contains metal oxides, sulfides, carbonates, or chlorides, and so on. Because they exist in compounds, there is a need for chemical reaction to remove the metal out of the compound, and this process is called reduction. Methods of extraction. There are 2 methods of extraction that you learn here. First is reduction with carbon. How do you reduce with carbon? You heat the metal compound with carbon strongly, and of course the carbon can reduce the metal compound into metal. And next, electrolysis. Electrolysis is a very powerful way of getting the metal out of a compound by using electricity. And using electricity, you're basically supplying the electrons back to the metal, so the metal ions can become the metal atoms again, and therefore you can obtain the metal from the compound. So take note, electrolysis makes use of electricity, and of course usually is higher cost. Now, this is a relativity series. As you can see down here, the first 5, okay, in the syllabus you cover only 4: potassium, sodium, calcium, magnesium. But if you include aluminium, aluminium is right after magnesium. So from potassium to aluminium, the top 5 are extracted by electrolysis, and they require electricity, hence their extractions are more expensive. And since they are extracted using electricity, these metals are only discovered in the last couple 100 years after the discovery of electricity. Before they discover electricity, there's no way we can extract this from the compound. How about the metals below aluminium? You can see that there's a carbon above zinc. Carbon, being more reactive than zinc itself, tend to displace zinc from the compound. For example, when carbon reacts with zinc oxide, you will form zinc and carbon dioxide or carbon monoxide. So the next 5, which is zinc, iron, lead, copper, and silver, we call the middle 5, they're extracted by heating with reducing agent. And so who is a reducing agent? Carbon. Carbon is a reducing agent. How about gold? Gold occurs naturally uncombined. Because they're so unreactive, they don't easily combine with other elements to form compound. Hence, you can extract, or you can say you obtain gold using physical method. So the top 5 is by electrolysis: potassium, sodium, calcium, magnesium, and aluminium. Please remember. And the next will be by reducing agent, which is zinc, iron, lead, copper, and silver. Now we'll focus a bit more on the reactions in the blast furnace to extract iron. And this is an example of reduction process, reduction by carbon. Iron is extracted from hematite. Hematite is one of the iron ore that's commonly found, and it contains a high percentage of iron. That's why it's commonly used to extract iron from the ore. Because this is a mixture and it comes with other sand and rocks and so on, other impurities. Now this is hematite. So in the blast furnace, you can see this blast furnace is easily 10-story high. 10-story, probably about 30-40 meter tall. And this gigantic blast furnace is made out of bricks. Inside the blast furnace is lined with refractory material. Now why is it so? Because the temperature inside blast furnace is so high that of course the molten iron form, the temperature is very high, and if outside is not made of material can withstand high temperature, probably the structure cannot stand for very long. Alright, and refractory material means the material can withstand high temperature before it can melt, and of course it can trap the heat inside. Now you can see that from the top, hematite, which is iron 3 oxide. Okay, first hematite is iron 3 oxide, Fe2O3, and hematite is not a pure substance. It's not a compound itself, but an ore. Ore consists of iron 3 oxide and rocks and sands and so on. And of course, you also add coke. Coke is actually carbon, the black carbon, and limestone, which is calcium carbonate. All these 3 substances added from the top go into the blast furnace, and of course, the waste gas escapes from the top. Now look at the blast furnace at the bottom. Hot air enters. Okay, The hot air is enriched with oxygen. Hot air is enriched with oxygen. In other words, it contains slightly higher percentage of oxygen compared to air. Air contains 21% oxygen, and this enriched with oxygen, probably 30 or maybe 40% of oxygen in the enriched air. And this hot air is preheated to about 750 degrees Celsius, because if cold air goes in, it will cause the temperature to drop, and it would this hot air is preheated to about 750 degree. Now look at the bottom. The molten slag is actually obtained on top of the molten iron. Molten iron is the bottom layer, and the molten slag, this is the molten iron upon the bottom, and of course the molten slag is above the molten iron. Why do you think molten slag is above the molten iron? Because molten means that they're both liquid. Why do you think molten slag will float on top of molten iron? Obviously, it has to do with density. So in this case, molten slag has a lower density than molten iron, so it can float on top. Now, let's go through the chemical reaction in the blast furnace. First, there's a production of carbon dioxide, and this further reacts to form carbon monoxide, and carbon monoxide reduce the reduction of hematite to iron, and finally the removal of impurities, mainly the sand itself. First, production of carbon dioxide. Coke, which was actually entered from the top of the blast furnace, burns in hot air, and this reaction is very hot. It produces even more heat and cause more coke to burn. Carbon dioxide is produced during this process, so carbon, which is coke, carbon dioxide is produced in this process, so coke, which is carbon, reacts with oxygen to form carbon dioxide. And this reaction is very exothermic. It means the reaction produces heat itself, and the furnace reaches over 1600 degrees during this reaction. Now next, how do you form carbon monoxide? Carbon dioxide, when it rises up, it reacts with more hot coke, and carbon dioxide is reduced by more coke in the blast furnace to form carbon monoxide. As you can see the reaction, carbon dioxide plus carbon give you carbon monoxide. Next, the carbon monoxide reduces iron trioxide. The molten iron and carbon dioxide are produced. So you can see in this equation, iron trioxide Fe2O3 reacts with carbon monoxide, the reducing agent. So this reducing agent removes the oxygen away from the iron trioxide, so the iron can be formed, and by removing the oxygen away, carbon monoxide becomes carbon dioxide. For every carbon monoxide, it takes in one more oxygen, so it forms carbon dioxide. And this iron will sink to the bottom. Okay, that's why you have a molten iron. Take note of the molten state, which is in liquid. Okay, molten iron. And this iron obtained is not pure. Okay, right out from the blast furnace is called a cast iron. It's in pure form iron. And the carbon dioxide escape together with other hot waste gases from the top. And take note, nitrogen actually escape. Where does nitrogen come from? Nitrogen coming from the air, right? We know that 78% of air is made up of nitrogen. So even in air enriched with oxygen, you probably have 60% of the air itself containing nitrogen. And this nitrogen does not react, hence it comes out from the blast furnace as nitrogen itself. And where does the carbon monoxide come from? It comes from the reaction between the coke itself and oxygen to form carbon monoxide. If unreacted, it will come out as carbon monoxide. If reacted, it come out as carbon dioxide. So there's a mixture of carbon dioxide, carbon monoxide being produced and come out through the top of the blast furnace. Now, removal impurity. What will be the main impurities inside the blast furnace? Because we obtain iron ore from the ground, naturally there's a lot of sand, and they are the silicon dioxide itself. So what happened is the limestone, which is calcium carbonate, okay, it makes out calcium carbonate and some other impurities. It decomposes at high temperature. Calcium carbonate will break down to form carbon dioxide and calcium oxide according to this equation. So take note, calcium carbonate in solid form, they break down to form calcium oxide, which is solid form also, and carbon dioxide gas. And this carbon dioxide gas actually is similar to the first reaction where the coke burned with oxygen to form carbon dioxide. So this carbon dioxide can actually react with more carbon to form carbon monoxide, which is a useful reducing agent. Now, so how does calcium oxide remove impurity? Now, calcium oxide is a metal oxide, it's a basic oxide. and silicon dioxide is a acidic oxide because it's a non-metallic oxide. So this is acidic, and this calcium oxide is basic. So when a basic substance and acidic substance react, it's something like neutralization. So this calcium oxide reacts silicon dioxide to form calcium silicate, which actually sinks to the bottom. Okay. Now, why is this an acid-base reaction? Why is it acid-base reaction? As I mentioned, a base, which is a metal oxide, calcium oxide, and an acidic oxide, which is silicon dioxide or silicon oxide, they react to form salt, which is calcium silicate. And this calcium silicate, take note of the state symbol, it is liquid. So liquid means it's flow down easily due to gravity, it flow towards the bottom, and because of lower density than the molten iron, it will flow on top of the molten iron. So remember, when you are asked to label the blast furnace, the molten slag having a lower density will always flow on top of the molten iron. So let's try this question. Which substance is a reducing agent in the production of iron? Now, in this whole production of iron, we only heard about one agent, which is a reducing agent used to reduce the iron trioxide. So which one does it look familiar? Of course, it's the carbon monoxide. Alright, it's a reducing agent that removes oxygen from the iron trioxide. Next, which statement of the production of iron from hematite is correct? Now, coke is used to oxidize the slag. Now, coke doesn't react with slag. Coke is reacted to form slag, the molten slag. So coke is not used to oxidize the slag, but it's actually reacting with silicon dioxide to form slag. It's not even redox reaction. Now, limestone is used to remove basic impurity. Limestone produces calcium oxide and is used to remove acidic impurity because silicon oxide is actually acidic. So this is not right, it's acidic. Molten iron floats on slag at the blast furnace base. Now, does molten iron float or sink below the slag? Obviously, it sinks below because slag has a lower density than iron. So therefore, slag floats on top of iron. And of course, given all wrong, the last answer should be correct. Hematite is reduced by carbon monoxide. Now, take note, hematite is Fe2O3. Fe2O3. Carbon monoxide. Once you remove the oxygen, okay, the process of removing oxygen is called reduction. So carbon monoxide remove the oxygen from the iron so the molten iron can be formed. Okay, Fe can be formed. Now, do pause and try this question. A. Iron is manufactured in the blast furnace using an iron ore, a coke, limestone. Name a suitable iron ore. Now, what is the special name, the special iron ore they learned today? Of course, it's hematite. Now B. Describe the essential chemical reaction that takes place in the blast furnace. Now, there are 5 reactions that take place in the blast furnace, and of course, you can find the answer in the previous slides. We have finished the extraction of iron and extraction of other metals. Now, you do not need to learn about electrolysis. That only is covered in the pure science itself. So electrolysis, basically all you need to know is that the top 5 reactive metals, the other potassium, sodium, calcium, magnesium, aluminium, they're extracted by using electricity. The process is called electrolysis. That's all you need to know. Now next we'll cover rusting. Now you should be able to describe the presence of oxygen and water as a conditions necessary for the rusting of iron. Now oxygen and water are always needed, both needed at the same time in order for the rust to occur. Now rusting is actually an oxidation process, a process where iron oxidizes to form iron trioxide. And of course, take how rusting can be prevented. Now look at this metallic equipment here. This is probably a farm equipment that is turning brown, and this brown actually most likely is due to the rust that's formed, not because of round painting. So you can see that all metals objects actually rust when they're left in the open. So what is rusting? Rusting is a corrosion of iron, or more specifically, oxidation of iron. Alright, rusting only applies to iron. Other metals like zinc, aluminium, when they form oxide, you simply say oxidation of zinc, oxidation of aluminium, but the rusting itself applies to iron itself. Only iron, okay? Now, hydrated iron trioxide is formed, and this is called rust. Okay? So this is called rust. And hydrated iron trioxide actually is brown in color. So let's investigate the conditions for rusting. Rusting requires two substances. One, oxygen. The second one is water. Now, rusting can be speeded up with in the presence of sodium chloride, which is a salt, common salt, and any acidic substances. In other words, if the environment is polluted by acid rain, being acidic, it causes the corrosion or the rusting of iron faster. Now, this is the experiment usually you'll be asked to investigate or explain. Okay, and these are the testing condition for rusting. Look at test tube A. There is a boiled distilled water. In something that's boiled, the gas actually come out from the water itself already. So this boiled distilled water has no oxygen, and the oil on top actually prevent oxygen from the air on top from going into the water. So this clean iron nails inside this boiled distilled water has water but deprived of oxygen. There's no oxygen. Hence, test tube A will not be a rust. The iron will not be a rust. In B, anhydrous calcium chloride is the drying agent. It absorbs moisture. So in this test tube B, there is oxygen. Obviously, there's air, there's oxygen. But because of this drying agent absorbing away all the moisture in the air in test tube B, the iron nail doesn't have water for it to rust. Test tube C, boiled distilled water. Now, boiled distilled water doesn't contain oxygen, but there's oxygen in the air above that can dissolve into the boiled distilled water. And of course, slowly dissolving will cause the nail to start rusting. But in this case, the nail rusting will not be that fast or large amount of rusting because limited amount of oxygen in the air above. Test tube D, sodium chloride. Sodium chloride, as you remember in the previous slide, sodium chloride actually can speed up the rusting process. It causes the iron to become oxidized to iron trioxide faster. So therefore, test tube D will be the one that actually rusts much faster than C, while A and B will not rust at all because A doesn't have air, B doesn't have water. So how to prevent rust? We know that rusting requires both water and oxygen. Make sure that the iron doesn't come in contact with either water or oxygen, or the best, it doesn't come in contact with both, so it cannot rust at all. So use a protective layer, for example, painting of metal gates, the fans, or even greasing. Greasing is using a layer of oil, especially things like bicycle, and plastic coating, electroplating, and so on. Alright, so let's go through a bit more detail. The plastic coating itself, for example, the hanger. Okay, a layer of plastic prevent exposure of the iron inside the hanger from coming in contact with air, oxygen in the air, or water. Hence, this iron cannot rust. And electroplating. The word electroplating tells you that it has to use electricity, and plating means covering a layer on top. So, for example, canned food packed in tin plated iron or steel can. Now, if you use iron or steel can, they will rust, and of course, the food become poisoned by the rust itself. But if you use tin plating over it, this tin is not reactive, and hence it can protect the food from coming in contact with any rust. The rust will not be able to form because tin actually covers up the iron. Iron cannot reach the oxygen or water, it cannot rust. Okay, let's take a look at this question here. In which tip does most rusting take place in 1 week? Now let's look at the first one. First one, there is tap water and there's exposure to air, which is oxygen in the air. Of course, rusting can occur. Test tube B, there's a drying agent, hence there's no moisture. Rusting is not likely to occur. Even if it occurs, it's very small amount due to the moisture in the air above. But drying agent will absorb away the moisture, so it will probably not rust at all. Now, boiled water covered with oil, so therefore there's no oxygen from the air above from entering. So oxygen cannot enter means that there's no oxygen gas. So water alone will not cause rusting. So B and C both will not rust. Now the last one, the tap water. Tap water contains what? Contains oxygen gas, but limited amount of oxygen gas. So some rusting will occur. But once oxygen is used up, no matter how much water you have, the rusting will not continue. So therefore, the oxygen in the water will cause the rusting to occur, but it will stop once oxygen is used up. Now for test tube A, it's very different because you're exposed to air, and this air can move. Okay, air above the tap water can move, and there will be a constant supply of oxygen in test tube A, so the near can continue to rust because air will not be used up and the water will not be used up either. Okay, so the most rusting occur in test tube A itself. Now next, we'll learn about recycling of metals. Now, why is there a need to recycle metals? And what are issues related to recycling of metals? Now, metals are finite resource. This is one key idea that you must always remember. Similar to the idea of petroleum, which is a limited finite resource. Once it's used up, you cannot get it back anymore. So, finite resources refers to something that's limited as non-renewable. But what's the meaning of non-renewable? It means that it cannot be formed within our lifetime. Something that's renewable is probably being reasonable, maybe 50 years, within 50 years, 100 years, it can be reproduced, okay, to make up whatever has been used up, and that's called renewable. But if it cannot be produced, cannot make up what is being used up already, that is probably non-renewable. Alright, so we use our lifetime as a rough gauge of something renewable or not. So if something takes 1,000,000 years to reproduce, of course it's not renewable. So is trees, the woods from tree renewable? Yes, it's considered, right? Because tree take maybe 20 years, 30 years to grow to its full size, and this is within our reasonable lifetime we can see something being renewed and reproduced. So trees are actually renewable sources of energy. Okay, but these metals all are not. Okay, once they use up means that they will not be able to replace. And this graph shows you estimate roughly how many years all this metal all in the ground can last. For example, chromium can last another 400 years, but iron another 300 years, tin and lead probably another 40-50 years. So before you even reach the end of a lifetime, maybe 70, 80 years old, you probably realize that tin and lead has vanished before you die, right? Gold and silver probably last another 20 years. Okay, but this gold and silver is not really used up. Okay, it actually go round and round. Any gold object they can be actually remade into new gold object and so on. So it's called recycling. So how do you recycle metals? How do you conserve metal to make sure they last very long? So there are two things. First, you reduce. Reduce means you find substitutes. For example, instead of using metals, you use other things like plastics. Alright, use wood and so on as a substitute for metal, so you use up so much metals. Now recycling. Recycling refers to it's a physical process. Refers to crushing. Okay, you crush. Okay, you melt the metals for making a new objects. Now, an old object, for example, the iron you use to make car bodies and so on. When the car expired, the car spoiled, is put in the trash and so on. You remove all the metal parts from the car. You remove all the plastics, all the whatever other material that's not non-metallic, and then you just melt down the iron and then make the new car bodies, new objects made of metal. So the process of recycling is basically a physical process, separating, melting, and then making a new object. But extraction definitely is a chemical process because extraction is getting the element, the metal from the compound. So commonly recycled metals, for example, iron and steel from scrap metals, aluminum from the canned food itself. Okay, lead is recovered from car batteries, very commonly used in car batteries. They can recycle and make the new one. Now, so what's the advantage of recycling? You need to remember a few advantages. Alright, so first, metals are finite resources. Finite means what? Means they're limited. So by recycling and conserving, you can last longer. You don't have to dig out so much from the soil, okay, under the ground. So whatever you have, you try to let it last as long as possible before you dig out whatever ores you have in the ground. So it can conserve and last longer. And of course, it reduces the waste and air pollution. Okay, by extracting metals, there's heating and so on, will probably produce air pollution. Because when you extract from the ground, you'll be digging holes here and there. When you extract metals, okay, the land you dig holes in the ground to get the metal out from the ground. After digging out all the holes, you realize that it formed a lot of pits full of water and so on. So the land actually is not very useful anymore because it's full of uneven pits, okay, and the holes and so on. So, but if you do not extract metal from the ground, you actually can use the ground for agriculturals and building of houses for people to stay and so on. Now, of course, you save money on extracting metals. Some metal extraction is very expensive. For example, aluminium, you require electricity to extract. So, if you do not extract aluminium but you recycle aluminium, actually it saves cost because the extraction itself is quite expensive. On the other hand, sometimes recycling may not be the best method of getting the metal because recycling can be expensive too. Alright, so what causes it to be expensive? So sometimes recycling can be more expensive than extracting metal directly from ore. So it depends. If your extraction method is expensive, then recycling comparatively will be cheaper. If the extraction method is very cheap, then of course recycling will be seen as more expensive than extracting itself. The cost, of course, it depends on collecting, alright, sorting out, separating and cleaning, and of course transporting. In a small country like Singapore, to recycle objects is very easy. Okay, you can easily collect metals from all over the place in Singapore and transport to a recycling center for recycling, and that doesn't take a lot of transportation costs. But in a very large country like US, Canada, or even like Russia, okay, if you want to transport a piece of trash metal, for example, car that is spoiled, okay, spoiled during accident and so on, instead of dumping it at the roadside, you want to tow it all the way to the recycling center. You probably need to tow another 200 kilometer, and the towing the 200 kilometer can be quite expensive transporting costs. Alright, unlike Singapore, the maximum you go from one end to the end is about 40 kilometer. So definitely our cost of transporting will be much lower. Now, other social issues: recycling produces less waste and poses less danger to human health. Alright, sometimes during extraction of metals, there are other minerals, other metals that comes with this metal that has to be dumped away, and it may pollute the water. Alright, less mining, more land to cope with increasing world population. Of course, if you mine already, like I say, when you mine already, the land can become barren, the land can full of pits and holes and filled with water and so on, become not possible to make good use of them to build houses or agriculture purpose. But if you mine lesser, this land can be used for other purpose like building houses, building of factories, or even agriculture, plantation and so on. Now, effort and time needed to educate communities and businesses to practice recycling as a way of life. Now, while we want everyone to recycle and of course to save and let our raw material, let our ores last longer, you need to educate the people, okay? Because very conveniently we can just dump our unwanted things in the dustbin and so on. But to recycle, it is a kind of way of life that we need to slowly educate the community to do it. Now, recycling can also cause pollution problems, because when you want to recycle, for example, lead from the car batteries, you need to melt it down. When you melt down, you can produce some harmful gases in the environment. So care must be taken when you want to melt metals and so on, because the vapor coming out, you could probably be heating up, melting down plastics and so on together with the metal. So all this can cause pollution. Alright, we've come to the end of the chapter.